His presentation will explain how fertiliser can move towards a carbon-free future to reduce its environmental footprint and the positive gains and opportunities that will bring to farmers and a growing world population. Mark, over to you.
Thank you very much, Stephen, and I'm hoping the screen is now sharing. Just a bit of housekeeping. There's a few deliveries that happen in the household, and there's 2 Labradors which can't be muted, so they might make their presence known if something does happen there. But I'm hoping the screen is sharing, and yeah, really pleased to be presenting today at the conference. Great lineup and a great subject. So the task given was reducing the fertiliser carbon footprint, the benefits to crop and the environment. There are, of course, as you might expect, some references to Yara within it, but I would say that Yara aren't exclusive in this arena. There's lots of investment going on, from inhibitors to green ammonia to all sorts in the industry, knowing that it's got to really tackle the issue that's associated with the product. So I'll just put that up in the one thing that Yara are fortunate to have is this global presence, because there are very few companies that actually operate in sort of 60+ countries. So that gives us a real need to address this on a very global basis. The last thing we want to be doing is exporting environmental responsibilities into other parts of the world. It needs to be a very global attack, if you like, in terms of meeting the challenge. So the scope for the next 30 minutes is really just to put a bit of reflection in there on understanding the carbon footprint of fertiliser, just a few numbers there. And you'll see from the footprint on the right, then you can understand why fertiliser is a topic whenever carbon footprints and greenhouse gas emissions are sort of discussed, because CO2 is involved, energy is involved, all those fossil fuels, and then we create emissions during that process. So invariably there's an issue when it comes to use of fertiliser, and we need to address that. So I'll just then highlight what the hotspots are, hotspots in terms of production and use, so that we just focus in on, I guess, what those the issues are and where they are, and then just to move through really to think about some of the low-hanging fruits that farmers, and there's a few names that I recognise on my participant list, which is great, in terms of where those sort of low-hanging fruits are by way of making improvements, and then the more medium and long-term opportunities towards improvements. So if we just put things into sort of perspective and where they are, then you've got there the emissions, which this was taken from a FAO stat document there, which is 49 billion tonnes of CO2. And then, but most importantly, you can see the percentages that are involved. So fertiliser production represents roughly 1% there. But also there's obviously indirect consequences further down the slide there with mineral fertiliser and N2O emissions. And then of course, manure usage, all involved, or all involving sort of nutrients and specifically fertiliser. Land use change, clearly always a big part of that picture, and something we want to avoid by sort of exporting, if you like, responsibilities. So you can see there mineral fertiliser 1.2%. And when I did the Nuffield back when Stephen mentioned 2011, then yeah, energy for fertiliser was 1.5% of global energy. So in some ways a very small number, but I guess some would say a very big number if it's just one specific item there. But 1 to 1.5% is always the number that's considered when it comes to fertiliser and global energy use. In terms of as the lead up to the Paris Agreement, then there are also numbers that were associated with that. So the contribution towards global greenhouse gas emissions highlighted there. And again, the numbers they used, fertiliser production 1.5%, and then the consumption, which is the use of the product at the farm gate, etc., 1.5%. Again, manures coming in there. So if we're using a nutrient plan and we involve manures and fertiliser, then clearly there's emissions involved with all of that activity. but again, the usual land use 12.5% figure coming through. So again, it just highlights here it's a bit of an issue, it's a problem, but also when you start looking at what the solution is towards it, then it becomes part of that solution as well. And as we look and head and have an ambition to be carbon neutral by production, we've got a lot of investment going into there. And then the second one down the list, which I'll just mention as well, which is this circular economy piece. And that's again really a big area of investment, and a pilot project looking to take all of the waste from London, which is millions of tons a year. Currently a project there that we've led with Veolia, where we look to take all of that waste from London and turn it into usable fertilizer. So there's some big circular economy projects ongoing as well, which will all help to improve carbon footprints and reduce greenhouse gas emissions. Then there's the usual sort of digital solutions that you'll be hearing about, farmer practice, how we can improve that. And then lastly at the bottom, logistics, and ammonia being a source of energy that can be used to power ships and move containers around. So investment in all of those areas to help really get somewhere near achieving some of the expectations from that Paris Agreement. So when we look at fertilizers, just to get into perspective which bit gives us the issue, and you can see there just a very simplified diagram of where we take the nitrogen from the air, just as a plant can do, or a bacteria or whatever. So we take the nitrogen from the air, and through that high energy intense process combine it with hydrogen to end up with the product there, ammonia. And that's really the central bit, because once you've got to your ammonia, then you can turn that into finished products, and the products that you would recognize being urea, liquid UAN, there, nitrates, NPK fertilizers. So but the ammonia is the link really between all of it. And the intense bit in terms of carbon footprint is the fuel and energy usage to get that reaction, which obviously is the Haber-Bosch process, and the hydrogen where that comes from and the source. And that really, the dominance there is being the natural gas or coal globally, and that's where the emissions, the carbon footprint calculation really shows and highlights. So that's the bit really to tackle. So how can we get to ammonia and then an improved carbon footprint? The other issue then we have during nitric acid production, during that process, which turns the fertilizer into the nitrates, as you would know them as ammonium nitrate or CAN, then that's where again we have an emission that needs sorting out, and that'll be one of the first things I just mentioned in a moment. Clearly the one thing that I would highlight is if you look at chemically the formula of urea and the formula of nitrates, then with one of those products you'll find carbon in it, the other you won't. And I think that's something that I'll pick up later on at the end of this. If we want to really think about carbon-free fertilizer, then we want to look at a chemical product that doesn't have that carbon molecule in it in that sense. So that will come back in a moment in terms of what the potential implications of that approach could be. So that's the sort of basic diagram in terms of where we are. In terms of footprints associated with farm produce, etc., then just a couple of highlights now. Then a project in Finland where they're looking to, with Valio, which is the processing co-op, then they're looking to be carbon neutral with their milk and dairy by 2035 is their target. And they've done a lot of scoping out of the farm to factory LCA, the life cycle analysis of the milk. And you can see why, again, fertilizer features in any of those calculations. So apart from the methane and the N2O emissions there that are highlighted, fertilizer production being that 4.5%. So that needs addressing. And then as you move down, as just mentioned, those field N2O emissions being all important associated with that fertilizer. So again, you can see where the numbers roughly feature out when it comes to farm produce, which is what we need to try and reduce. We can also do similar calculations as have been done on the long-term experiments at Rothamsted, that great research institute with the oldest experiments in the world. So we can do those calculations on those field experiments, and we come out with there looking at where the carbon footprint sits at the economic optimum N rate for a wheat crop per hectare. And we can see immediately where some of those hotspots are, two of them notably. So the top sort of rather dirty green looking colour is the N2O emission associated in the field, and then further down with the orange amber being the N2O associated with the production. So two real hotspots there which need addressing, and that's been fundamental in trying to target where investments are made. So really, and back a few years ago, that production was the big issue. If we look then, just to highlight, I think the next sort of few slides are going to be very much talking about or just mentioning that production side of things, because as you move along to decarbonize the sort of chain, the value chain with solutions, then you start with production, obviously, and the energy consumption and the raw materials, produce it into a fertilizer. You've then got the shipping side of that, but then you move to really that sort of where you come in terms of the farmer, your use of the product, and then perhaps the demands that the end consumer will put on what product is wanted. They then equally have this sort of key part to play as we look to reduce waste, which is then the circular economy piece going along the bottom, back down the way, which can be turned into raw materials for production again. So a nice circular piece there where we can get involved. So production and logistics, then I think that's where we've seen big strides initially back in the early 2000s, when abatement technology was being explored for nitric acid plants, and a huge investments were made. We knew that during that nitric acid production, the plant then N2O was emitted, and we needed to understand and sort that out. And that's something, that word has been used for a number of years now, but still maybe as farmers who aren't dealing with fertilizer every day, goes over your head at times. But think about that and remember that word abatement when it comes to thinking about choices of fertilizer, because that technology that was developed, and yes, it was Yara that developed that technology and then sold it on to any other companies that were interested. And literally it's about a catalyst, as you can see in the picture there, that converted, when it was developed, N2O, which is that greenhouse gas, very powerful greenhouse gas, back into N2 and O2, so inert minerals there, so or gases, so that we end up sort of really reducing that component of the issue. And what did that do? And really a lot of Western European fertilizer plants would now have that technology. Yara's were all finally fitted at the end of 2009, when that was every factory had that catalyst fitted. And that, as you can see, had a huge impact on the carbon footprints and therefore the carbon footprint of growing a crop. And I've brought back up the long-term experiment there in terms of what that did. And you can see the orange bar that was highlighted earlier being the big issue before the catalyst. So once we've installed the catalyst, then you suddenly move that down by a considerable amount. And it's typically around 90% is the sort of figure that's quoted in terms of once you install that catalyst. Further developments are going to be made in terms of that catalyst, and we'll take that figure towards 95 and 98%. So really removing the N2O emitted at the factory point there. So that obviously left then the glaring issue still with N2O emission in the field, and that's something that, again, we'll just come on to slightly later, because that has to be considered. What does that look like by way of carbon footprints? And this is where, as farmers, you can start thinking about different measures of success. And this is a 2014 large data set used to look at the different carbon footprints associated with fertilizer in terms of where it comes from in the world. So immediately you can start to see, and this is kilos of CO2 equivalent per kilogram of ammonium nitrate N there, which is highlighted. And you can see Europe at the left-hand side there of the screen down at 3.42. And as you move towards coal-based Chinese production, then you can see the difference, 3 times the figure. And generally that's the changes as you move from natural gas through to coal in terms of your choice of feedstock, then you increase the carbon footprint. You can see there you've got whether it's Russian as well or other Asian countries, but a big difference just purely when you do that calculation around CO2 per kilogram of N. If we, I've also got up here just the comparison with urea. So because urea and ammonium nitrate dominate the scene, and urea particularly across the world, then again you can see it's important to, whenever you're doing these sorts of comparisons, to look at what that means in terms of, or account for everything. With urea, you have CO2 that's emitted out in the field, therefore that has to be part of the calculation. So very similar to ammonium nitrate there, just slightly above it when you do put those two figures together, 3.5 roughly. So again, differences in terms of where that product originates from in terms of its production site. So really important to start homing in on some of these key issues. So I guess the first steps to reducing the carbon footprint is to really consider the fertilizer and the nitrogen is really what we're talking about here, by way of a different measure of success than perhaps you've thought of in the past when purchasing. So that would be, look for that term abatement, abated nitrogen, because you'll be bringing fertilizer onto the farm that's got a low carbon footprint compared to unabated. And then also to consider that region of the origin of where it comes from around the world, because that again will determine what your starting point is by way of a carbon footprint. If we move through, then I'm just going to go back now in time, because it's quite an irony here as we now look. And back in 1905, when Yara, as it was then as a company, different name, started its and became the first company to extract nitrogen from the air by way of a process. And that happened on the back of 3 people, but 2 notably. One asked for the most powerful electrical charge that he could find on Earth, and a scientist said, I can help you with that. And then there was a third person who had the money to help the process along. And they ended up using electrical charge generated from hydroelectric power. And ironically, of course, that was a very green start to fertilizer production. But Haber-Bosch came along a few years later, and clearly the economics changed. But what fertilizer did at that time, and it's been highlighted on many occasions, and just one stat here is, one of the greatest things that came about in terms of saving lives. Of course, at that same time, as always, unintended consequences of what had been produced perhaps weren't seen at that time, and that's what we're now thinking about as we move forward. So really important product in terms of lives across the world, with roughly 50% of the population having their food produced from it, but it has had those unintended consequences. And I guess that's why we now need to look at how we can change away and perhaps look back, and certainly that's what we're doing, is looking back to that original process and others, and thinking how can we get towards carbon neutrality, and our target is by 2050. But in terms of putting sort of more measurable dates on it, we would hope to have some inroads made into that within the next decade, and hopefully 2028 we'll start to see the first signs of a different fertilizer coming along, and that's our ambition, even if it's a pilot production, a limited production, but the journey is certainly well underway. How do we do that in terms of reducing it? Then obviously we need to produce zero carbon nitrogen. That's what the game really is, so that you as farmers can benefit from that. And alongside of that, we need to reduce and have solutions to help you with that managing the greenhouse gas emission in the field, as we highlighted. We can also use the solution to be the carrier as well and ammonia, and green ammonia could well be an energy source that could be used to really mitigate carbon emissions through shipping and sort of carriage of whether it's fertilizer or produce. So one of the examples just given there is, and there's numerous around the world happening, but Yara's involvement in Australia with energy or NG looking for zero emission ammonia. And that's really about designing a green hydrogen plant using electrolysis to produce green ammonia. And that has a huge reduction in the CO2 emissions and future costs. But there's other projects going on where hydroelectrics have been used. And just to say, this isn't, in some ways it's new, but it's not new. Then our factory in the right up in the north, up until 1991, was producing green ammonia, or some green ammonia, through electrolysis, through its production. And there's examples there, the dates on that, which have been utilised over the decades. So there's plenty of examples out there where we can see this reduction happening. And our collaboration with Nel, which is cited on the slide there, is another project that's ongoing in Norway to look at this green ammonia production. So where does that sit back, if we bring back our picture that we had right at the start in terms of our hopes here, then highlighted the Haber-Bosch process there, where that nitrogen is combined with hydrogen, and obviously hydrogen came from the fossil fuels that I mentioned. What the game now is to use electrolysis through use of renewable power to create that hydrogen to combine with the nitrogen, to then turn it into the green ammonia, and then we can turn that into the nitrates that you will be very familiar with as a green ammonium-based product. This is where I mention urea, because clearly one of the issues, and I mentioned it early on, that the chemical equation of urea gives it away in the sense it has carbon in it, and that carbon comes out when you put the product onto the field. If we move to a green basis there, then the CO2 required for urea production isn't there. So you do end up with urea as a limited option unless you look towards green CO2 to be part of that process. So this does have big impacts in terms of fertilizer production globally and across the world, in terms of what that means for sort of ongoing manufacturing. So it's something worth noting, and something all too often forgotten is that carbon element that comes in to urea. And there'll be a lack of CO2, of course, going into fizzy drinks that currently has it. So maybe we'll be moving to flat drinks in the future. But as I said, there's plenty of examples from whether it's Yara or other companies out there who are really moving in this space now to create green ammonia, because it is seen as a big step forwards. So the future looks very different in that nitrates are most likely to be the dominance in terms of carbon free. Green ammonia is just that intermediate step in the manufacturing process, but that's really where it all very much starts. To produce urea in the carbon neutral way, then that would require a massive amount of green CO2. So there's an issue there to consider. And urea application itself, generally across the world, uses higher application rates because of the lack of efficiency. And it, of course, releases CO2 in a rather uncontrolled way out in the field. So lots to think about when it comes to that fertilizer choice and nitrogen going forward, but real optimism for that greener future. Now, of course, there are, and this isn't a walk in the park by anyone, this takes huge financial investments, to produce it, and what you end up with, and this is why the Haber-Bosch cheap energy, if you like, was taken on board back in 1913 there, because you just look on the graph there to see the difference that moving to whether it's electrolysis or biomass with no net direct emissions associated. The difference by way of a cost per, and it's in US dollars per tonne, is very different. So that is, of course, going to end up with a discussion around who pays for that, and whether it's the consumer that's prepared to pay for that, or whether it's more, and I suspect this is the way it'll travel, is that the cost to the environment is probably what will come into play more. So those penalties associated with high carbon footprints, etc., will be the ones that, which is where it starts to level out, I guess. But that is going to be a huge debate, and certainly in the whole sort of value chain, who pays for that big difference that comes about as we look to be more carbon neutral. So the three steps, there's a third step there. I mentioned the abated nitrogen, consider that region, but the third one, and within the decade, start to really look at where green ammonia might be an option as you get into that. And we hope, yeah, as I said, 2028 could well be a sort of pilot year, which isn't too far away when we hear of in some discussions that we have. So when it comes to the farmer, retail and consumer, clearly a lot going to be required there in terms of understanding, as I said, the financials there, but also to think about from that farmer point of view what you can do as well. And I think this is where I've just highlighted again that field emission. And I think really start to have a focus on nitrogen use efficiency. That has a real win-win. Firstly, you're improving nitrogen efficiency, which means less loss in the system, which means positive environmental impact. But also that's a win-win in terms of financially. And we know that we can get up there towards 80%, and that should be a target that you set. So start benchmarking yourself in terms of efficiency. I think be very cautious here, I would say, about using yield when calculating nitrogen rates. It's something you would have heard me talk about a lot, because it's a gripe of mine that if we're not careful, we can end up being way too optimistic with our yield predictions and over fertilize. So really do focus in on the crop, and until we've got much better yield predictions, then be careful with that one. But really use technology in the field to understand and get nearer to that optimum N that we know we can do, so to drive our N efficiency. Going to need to avoid large applications in those wet soils or when rain forecast. That is a challenge with the start of the season, because in those wet waterlogged soils then we end up driving emissions up. And really do look towards the technology that's out there that's being developed, whether it's digitally, physical products that can help towards improving that efficiency. Because the one thing we really don't want when it comes to emissions is those waterlogged, compacted soils. We're really wanting well-structured soil, and that's very much what is on farmers' agendas at the moment, and a real great agenda to have, because if we improve that soil structure, then we really do improve the position we have when it comes to emissions. So really do have a focus in on that, because that will help nitrogen use efficiency. It helps reduce those N2O emissions during those difficult times. And maybe as we get better weather forecasting, we can be much more targeted about fertilizer use, maybe more applications, but certainly avoiding conditions that drive emissions higher. So have focus on soil management, as many of you are. Finally, then, there's lots of partnerships going on around the world, from Yara at the end, at the sort of real manufacturing side, but then through with partnering, and Yara IBM have a partnership globally looking at how we can bring further sort of carbon management and digital platforms together to improve the position. So look out for those partnerships that are being developed with that real common mission across the world, which is improving the on the climate change landscape. And then also financials. Then one thing that's interesting, Yara refinanced itself 2019, and what it did was build in financial incentives towards achieving its targets by 2025 in this case. So again, there are ways out there which the economy can start to really drive incentives. So the quicker they get to their targets, the cheaper the money effectively. So again, there's good fiscal policies coming through, and credit facilities, which can be matched up against climate ambitions. So there's some really innovative ways out there which are developing to help encourage people on the way towards carbon neutrality. So yeah, that gives you a bit of a flavour. Hopefully I'm still on time. Yeah, lots of exciting things going on in the world of fertiliser and circular economy, which will bring benefits, and the future will be certainly different, I think. So look forward to any questions, and certainly pick up conversations further on. Thank you.
Mark, many thanks for that, and outlining the energy surrounding the manufacture and use of fertiliser, and how it's possible to move towards a carbon-free future by reducing its environmental footprint even further at both factory level and, of course, on farm. And as you said, Mark, there's real optimism for the future, but a huge financial investment will be needed, probably on both sides of the farm gate, I suggest. And given, I'd like to just set one of the questions rolling, given the further improvements which fertiliser manufacturers will need to make to achieve a low carbon footprint to meet the targets set by government, or the even more ambitious net zero target set by the NFU, which will we see, what will be the impact? You know this question's coming. What will be the impact on nitrogen prices in particular?
Yeah, I think that's the single, I guess, biggest issue here, in that sense, that the least cost production sort of model is what has driven things, and we've ended up to the position where it is today. Invariably, Yara lost out in those early years, which is why it then moved away from the renewables, if you like. So we've now got to the position where we've got to get back to that. But I think the whole area, I guess, has been masked by the true costs and the real costs that are associated with reactive nitrogen. And that, I guess, is where the position will end up playing out in terms of who pays for that in terms of a penalty. And of course, Yara will be part of that. Action that farmers take will all be part of that. And consumers who then make choices will be part of that. So that's why, and I put the graph up there, the extra cost that's required to produce green fertiliser has to be put out there now, early on, because it's real. It's a real issue. Now, one thing for sure is we are trying to do this from a farmer point of view, and a global position of satisfying the needs and getting that, addressing the climate issue that we all face. But I think the whole concept is, what is the true cost of a product is where it will fall down to, in terms of, is fertiliser today too cheap associated with the extra costs that it places on the rest of the world? And I guess that's where the levelling needs to come into, in terms of what is that true cost of anything we do, as you bring in different measures of success other than just the cost of production or a yield measure. So I don't think I've answered it in some ways, but equally I've highlighted there is an extra cost here, and it'll be up to us as a producer, manufacturer, to try and keep that cost to an absolute minimum in terms of production, but to remain profitable in that new world, to keep investing in further technology, I guess, and innovation.
I think that's a good point, and nobody underestimates the value of all fertilisers actually in driving down the unit costs of production, if we're to be more competitive in our new the dynamic global world of agriculture and food production. It is important, and we mustn't just look at the cost of everything and forget about the value of nothing, as the old saying used to go. There's a follow-on question from this. Well, it comes from Alan Morgan, I think. Well, when do you think companies will be over the lump added costs for development changes? How long is it going to take for them to write down the development cost of developing greener fertiliser?
I think that's, if you like, happening now by way of all these pilot studies, that there's a lot of investment going in, and whether it's hydro, whether it's solar, whether it's sun, then, and yeah, as we move through to late and 2028, that sort of time, then I think we'll start to really understand which ones perhaps have got the scalable ability to be churning out the sort of millions of tons. So I would, yeah, it's going to be a 10-year process, I guess, of really understanding the ability to scale up something. There is, of course, the other side of things, which could be a complete reversal, where we use technology, and there's already technologies that are being experimented with small units that are on farm, and they turn waste into fertilizer. So let's not discount moving away from a model which is a very huge factory to more home produced on farm technologies that can enrich waste or improve the analysis of other products that come onto the farm. So I think you know, we can go in a number of different directions with it as investments are made to try and find which one is the right one.
Thanks, Mark. As you say, to finish on again on another one of the positive points you put out, but we're in this together. You know, it's no longer sort of the supply, trade and farmers. I think we've got to work on this one together, hopefully.
Yeah.
And moving away from cost. Farmers can already help, as you have said on a number of occasions, by benchmarking their fertiliser use efficiency, and by focusing on crop needs and using the technology which is already available in the field. And we can do that now rather than just, and it's important to do that now, rather than just waiting for yourselves to come up with an even more carbon neutral fertiliser products. Now, so thanks again, Mark, for your presentation, for answering the questions.